Hey, there we are. Look, it's me, John Park, and this is John Park's Workshop. Thanks so much for stopping by today. We have exciting, fun stuff in store for you today. In fact, we're picking up where we left off last week with our pixel art display, and this week we're going to be doing animation, sprite sheet animation. I'm going to tell you all about it, how it works. It's fast and fun and easy on the Matrix portal, running on our Matrix displays. We have a question coming in from the Discord. Where is the stash, John Park? So that's an excellent question. I don't know where it is now. I think I cut it off. That's what happened. But if you want to ask questions like this and get cagey answers, you can head over to the Discord. That's at adafru.it/Discord. That's where a lot of our chat is happening. I also try to keep an eye on the YouTube chat over there as well. Lars has it. Wouldn't Lars be weirder with a mustache? Good. All right. So, yeah, thank you. And hey, thanks, C. Grover, for the audio check. Matambale says, how do we know if it's really John Park? Another excellent question. I can't answer that one. All right, well, let's get to some stuff here. What do we have going on today? Hey, the help wanted. Did you know that if you're interested in looking for work, you can throw your resume up here on the jobs.adafruit.com site. It is free. It's free to post. It's free to post a position. It's also free to put your available for hire there. If you look at this available for hire section, a lot of great skills out there on offer, so if you're looking for someone to help you out with something, this is a great place to look. A lot of technical services, a lot of makers, a lot of embedded developers, web developers, coders, engineers of various stripes. They're all there, so go head over to jobs.adafruit.com if you're ever looking to hire someone or looking for work. That's what I say. Go check it out, would you? All right, hey, let's talk about a product pick of the week. So as you may know, I now do a product pick show on Tuesdays. This Tuesday was no different. This was the product I picked for the week. It's the BNO-055. It's a 9 degree of freedom sensor. There it is in my mouth for some reason. And what I wanted to do was show you a little highlight, a little recap of the video. So check this out. This is the product right here, BNO-55, the 9DOF orientation sensor. First of all, what's 9 degrees of freedom? That means that this is giving us essentially rotational positioning data from 3 axes of an accelerometer, from a magnetometer, and from a gyroscope. All of that data can be massaged and fused to give us the thing we really care about, which is a heading, pitch, and roll, which is where is this thing pointed in space. Like we said, these can be used for navigation, for robotics, for personal fitness, for drones, for toys, for laptops, and that is why this is my product pick of the week. Yeah, there you go. That's the one. So come on back next Tuesday and you'll see another one. And one of the things I'll mention is that we tried something new this week, which was there was a bonkers discount on that sensor. Normally this is a $19.95 board for this Stemma QT 9DOF sensor. We halved the price during the show. So only during the live stream we have a special discount going on. So that went down to $9.80 something cents, I think it was. I can't do that math. But available just during about the 20 minutes or so of the live stream. So to do that next week, go head out to the blog, and there will be a link that shows you where we're posting or which product it is. And if you find that product page, we won't make it too difficult. And watch the show right there. It's embedded right in the product page itself. You'll see a discount suddenly appear. So please have a look next Tuesday. It's the same time as this show, just a different day. Tuesday at 4 o'clock Eastern, 1 o'clock Pacific. All right. Oh gosh. If you head over to Discord, and I discourage you from doing it because it's creepy, but if you do, you're going to see Lars with a mustache. Salvador Lars. All right. Hey, enough of this. Let's talk about my MakeCode Minute. Let's do it. All right, let's get set up. Excuse me here. All right, let's throw some things on the screen. How about that there, me there? Yeah, that'll work. There it is. Okay, so for the MakeCode Minute today, what I wanted to do was build a little button combo gizmo, sort of something you might use as a starting point for a puzzle of some kind, perhaps, or a sequencer. But what it'll do, if you look here, I'm going to click left, right, and it's going to play back in order, left, right, left, right. If I go right, 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 left, it'll play back right, 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 left, and so on. And so doing a little echo, little button entry echo like this in Circuit Playground Express and MakeCode is pretty straightforward. If you look at my code here, the main thing that happens is that, this is the secret, I've created a empty array called the button list here. So when we start out, that array is empty. As I press my A and B buttons, get back here, there you can see, I call a function, same function, I just give it a different argument. Here's the function, press a button, and what it does is, as long as the length of that array that I started out as empty is underneath 4, then I'm going to add, wait, is that right? Add a button press. Yeah, if the length of the array is equal to 4, then I'll add a button press. And if you look here, when the length of the array gets to 4, we loop through. I think I have something wrong in there, sorry. I think that's while it's under 4. I must have changed something here. But while that array is underneath 4, we add button presses and we record into the array which one we've pressed. Then when we reach 4, this is where equal 4 makes sense, we go and we play the pixel color at that button item, and we choose a color from a little array list that I made as well. And I'm just blinking the button that's near it. So this is, I think, button 3 and button 7, or NeoPixel 3 and NeoPixel 7 as I press those, something like that. So pardon for the mistake there. I'll clean that up. But that is how you can create a little echo, blinky echo, using your Circuit Playground Express inside of MakeCode. And that is your MakeCode Minute. All right, yeah, sorry about that. I'm going to confuse everyone with that one. I think I will redo that video before we publish it, because I must have copied over a mistake version, not the one that's running on my board. In fact, just for kicks, let's see if we can load the one that's on the board here. This isn't always straightforward with my setup because I have a lot of different items plugged in. What I'm going to do is, let me open up the little window there again. You can see I've gone into bootloader mode here by pressing the reset button. And then inside of Circuit Playground Express, I'll go to the home and I will go import a file, choose a file. We'll go to the circuit playground cplay boot and open up this current UF2. That's the file that the MakeCode gets sort of compiled into and pushed to the board. Let's hit go ahead. It's opening it up. And no, that is correct. All right, why does that work? What have I done? If the length of the array is 4, set the pixel. Oh, that's the playback part of it. Yeah. Add a button. If the length of the array is not 4. Was I just? How about that? Yeah, look at that. That's the is not equal to sign. I bet someone noticed that in Discord. I was just a little too far away from it. I need my glasses on. That's the problem here. Oh, look, suddenly it comes clear. Yeah, that's as long as that array was not 4, then we add to it. So code was right. I was wrong. Sorry about that. All right. I'll dare to take my glasses off again for a bit. I don't like how it reflects that light off of there, so that's why I try to take them off. I swear I'm not trying to be vain about it. I like my glasses. But okay, so let's now talk about a arcade game pick of the week, shall we? Also in the Chrome browser here. So this arcade game pick of the week is called Attack of the Dots, version 1.2. Attack of the Dots. Version 1.2, and this is by Bill O. Coding, and I found this in the forums, actually the forum.makecode.com in the arcade section. And here it is. I'm gonna, whoa, watch out, because it's fast. So I'm that little black dot, and I am trying to get away from that cluster of bad guy dots. And you'll notice they follow me wherever I go. They also move at slightly different rates. They have different velocities from each other. And you'll notice if I get hit by one, I get hit by them all really quickly in rapid succession. Let's see if I can get hit by just one. There we go. Lost some hearts. If I go over that coin, I just picked up a few more hearts. I actually edited this to the code to give myself extra hearts. So before I died again already. So I wanted to show you, first of all, one thing I really love about this game is the very, very simple players. There's something about focusing the gameplay by just having dots. So your player dot is right there, one dot. You could make this a 1x1 canvas for the sprite, in fact. Same with the bad guys. And this is how the velocity is handled. So you can see these different enemies. Enemy 1, 2, and 3 are made. And they follow your sprite with different speeds. So speed of 50, 55, 53. So they have their different speeds. And then when you get hit by them, there's some overlap code that causes you to lose your hearts. I actually was playing around with giving this a little bit of a delay. There might be other ways to adjust that so they don't just immediately kill your player. But that is my game pick of the week. It's really nicely done. One other thing I wanted to point out is I really like the use of this highly detailed tile maps. You'll notice that the little background there has all these little dots in it, so you can get a sense of your motion on the screen as the camera follows you around that big tile map. And before I died again, I hit the mute button, so we didn't have to hear that sound. All right, so that's my game pick of the week, and it's called Attack of the Dots by Bill O. Coding. Good old Bill O. Coding. There you go. All right, let's see. Now what are we up to? I think it's time to get into our project of the week. So like I said, we did a bit of pixel art as a slideshow last week. So these were still images, individual images, that we are able to just bring in different bitmaps pretty quickly, one bitmap to the next. And then I asked, actually, Lady Ada said, okay, how about doing animation on this? And we talked to Melissa. She was able to come up with a really neat, succinct use of our tile mapping or tile grid for sprite sheets that's part of display I/O. So first of all, what am I talking about? Let me show you an example. I'm going to rearrange a camera actually so I can show you a matrix portal. There, that should work. Let me pop that screen on for you. Okay, so you can see here I've got nice matrix display, and I have a little animation running across it. And what I'm going to do is actually advance to some different ones. So what we've got on here is, this is the matrix portal plugged into a 4mm pitch. I think this is the 4mm pitch 64 by 32 display. This one is a pretty good example. In fact, let me show you one that I made. I created this animation this morning, this one right here, so that we can really dissect how both the animation works and how the sprite sheet works. So you'll notice a few things about this one. I've got a little number counter in the corner here. So this is 15 frames of animation that I have. And you'll also notice I put a border around it. I put this red border around it. And the reason I did this is because I want you to see what each frame of this animation looks like in the context of what is essentially one big long graphic that is being used as a sprite sheet. So let's pop over to this program here. I'm going to move my camera a little bit there. That should work. So this is the program I used. It's called Asprite, A-S-E-P-R-I-T-E, Asprite. And I used this last week to show some still graphics, some still image and creation, pixel art creation. You'll notice here I've got a pixel map grid turned on, a pixel grid turned on, so that I can see my individual pixels. So you can see here, this is 1-to-1, the same as that display, 64 by 32. And it is, we'll come back to this in a second, but you can see here this is a series of animation frames. And the way that we're loading those onto our board, onto the matrix portal, is as a single BMP. In fact, let me see, I'm just going to open up that sprite sheet. And in fact, I'll grab it right from, can I grab it right from the board without too much trouble? Probably. I'm going to throw on my glasses again so I don't make any weird mistakes. All right, volumes, circuit pi, BMPs, and this one here is Blobo 3, I named it. Okay, so there you can see that is what the sprite sheet looks like. It's a single long BMP image, and each of the tiles within it is this 64 wide by 32 high section, but the whole thing is whatever that's 512 pixels tall, so that's 15 times 32 is the height of this thing. So that's what the BMP as a sprite sheet looks like. And then what happens in code is that one image file, that one BMP raster graphic image file, is loaded onto the board, onto memory, and then the display I/O is calling different tile grids of that sheet. So you can kind of think of it as the sheet just kind of moving by, kind of like a film strip. And that's exactly what it is. It's a pixel version of a film strip. It's just moving these through in front of our view, if you think of the display as sort of the projector or the lens of a camera. It's not a perfect metaphor, but I hope that gives the idea of what's happening, is that we're actually just telling display I/O to look at some subsection of this bigger graphic. Also, by the way, I'll point out, Melissa, Maker Melissa, is in the chat, which is great, because if you have questions about this, you can ask. And the first question FX Music asked is, did the Metro M4 Express Airlift with an LED matrix also have the capability of doing this? And yes, it does. In fact, almost every project that I've done with Matrix Portal can also be done with Metro M4 Airlift and vice versa. Often with no change, because it's generalized in Matrix Portal. Yeah, in fact, Maker Melissa says, yes, no modification necessary. I tested them. Smiley face, so thank you. All right, so that's the graphic that is sitting on the board. And then when I, let's look at the board again. Then when I run the code on here, what it's doing is it is loading up the tile grid, or the sprite map, the sprite sheet, and then it's playing through those. And there's some adjustments we can make too. So let me show you the code here for a second. If I hop over to Atom, this is the code I'm running, and we have in here specified a sprite sheet folder, so that's where to look. It's a directory called BMPs. We have a default frame duration. So right now each frame is holding for 100 milliseconds. So what if we want this animation to go by a lot faster? Let's either change the default, or we can change an individual animation. So I'm just going to change the default right now. So let's go to 0.05 seconds. And I'll hit save on this. And now you'll see, let me hide my window here. All the animations are going to go by real fast. If I hold down the up button on the Matrix portal, that will start just looping a single animation. It won't advance to the next sprite sheet. And now if I go back to the one we were looking at, there we go. Now you can see this running super fast. And of course we can slow that way down. Let's drop down to half speed. Hit save, and you can just watch them all. Okay, so now they're actually kind of causing funny artifacts in my video. If you get the frame rates just sort of synced with the frame rate of your device, you can have problems. In fact, I wonder if I can fix some of that ghosting just by changing this slightly. I'm going to change this to 0.21. No, it's still going to get those. If you really want to study these, you do like a half a second per frame. So you can see, yeah, you can totally see the refresh there. All right, so I'll go back to 0.1. And so this is kind of a nice default I've found for these animations. What if you want to slow down just one of them? And in fact, I've already done that in here. If we look at the code, there are a couple of important variables here at the top. There's default frame duration. There's auto advance loops. So I'm having every loop play twice right now. You could set that to 5, 10, 1, whatever you like. Then we have these overrides. So these, let me zoom in a little for you there. These are the names of the specific sprite sheets. And I've told the 3 rings sheet to play a little bit faster. So a little slower. Instead of 0.1, it's at 0.15. The ball hop is quite fast. So you can see this one right here. Again, if I... Okay, this little ball hop one. Let me move this a little smaller for you. Okay, so that's running at 0.05, so that's faster than average. Here it was at regular speed. So this is kind of nice, and I spoke with Melissa about this as we were working on it together, collaborating on this on the code. And I said, you know, there's a few different, there's sort of 2 distinct ways that people handle animation in sort of multimedia software, less so in traditional animation or games. But one thing you'll find in software applications sometimes is a notion of variable frame rates. So having a frame that, well, GIF animation does this, right? So a GIF has a very limited number of frames that you can play every frame at a different frame rate from each other. So you could have something hold, let's say something flies up in the air and hovers, you can hold it for a second, but then the rest of the frames might have a consistent frame rate. So we decided not to do that because, first of all, that's confusing to traditional animation, which is where my mind comes from, traditional CG animation particularly. But also it gives us the ability to use these sprite sheets in a sort of one-to-one way. So what you see is what you get. If we look at, let me go back to ASprite here for a second, and let's look at some of these other sprite sheets that I have loaded onto disk. So here's the ball hop. Okay, so this one you'll see, there's the first frame. It's blank, then it's just starting to come into frame. And then it's into frame, falling, then we do a little anticipation stretch, then squash when it hits, stretch off and reform at the top, couple of denser frames there for a hold, and then it falls again and sort of repeats it with a smaller bounce. So it's nice to be able to, particularly if you look up like traditional animation, if you look at some of the Illusion of Life or Animator's Survival Kit, some of the sort of seminal animation works or websites where people are teaching animation, you'll find things done with multiple drawings if you want to hold, not changing the frame rate. So that's why one of the reasons we chose to do that. Melissa also said that would be easier, so good. Otherwise, we'd end up with like big tables of which tile grid is held for what time, and that would get sort of maddening to try to edit and adjust. So that's why we chose it that way, and that's also in keeping with the way most of these pixel animation software work, where you'll have frames, hopefully you'll keep them at consistent frame rate, and then when you make your sprite sheet, you'll get a one-to-one. If we look at the animation scene for that one, let's pop out to... let's see, Sprite has a very traditional file browser, by the way. It doesn't have shortcuts and convenient OS level things, so I have to remember where stuff really is. User, there we go, Jep, Adafruit, transfer, projects, pixel art, look at all these projects. There we go. Sprit anim, I misspelled that, ball hop. Oh no, did I not save that as a... I never saved the real file. That's probably just open somewhere. All right, let's try a different one. 3 rings. Why do I not have? Oh, because I didn't generate them in here. I made some of these elsewhere. All right. This is kind of neat though. If I open up just the first one, it'll ask if I want to open it as an animation because it sees the sequential files. So I'll agree to that. So here we get our timeline back. You can see this little rings moving. So for this, by the way, I was sort of channeling a type of Mario or rather Sonic gold rings type of thing. Just a quick and easy thing. I actually did this in 3D and just rendered it super tiny, which is a nice trick for getting good-looking lighting and stuff. That would be very tricky for me to do that in my head in 2D. I wouldn't get that right. So that started out life as 3D. So let's see. I think that covers what I wanted to cover. If we look back at our code, let me throw up some pretty animations, and we'll take a look back at the code. I'm going to expand this a bit. There's a display I/O guide in the Learn Guide system that you'll want to check out that describes sort of the hierarchy of sprites and groups and tile maps. And if we look at the code here, you'll see we're using display I/O. We bring in the matrix portal library as well. I mentioned some of those variables and how we're using them. Then we set up the display. We set up this one sprite group. So we only have a single sprite group, but then we append the bitmaps to that. The buttons here you can see are being set up so that we'll be able to pause and auto advance. So let's pause again and put my little blobby animation because I like that one. The files are grabbed from that BMP folder. The names are created as a list. That's our file list that we'll go through, the sprite sheet folder. And then we have images being loaded as bitmaps. This one right here you'll see is where we get the tile grid per bitmap. So you can see these will be different heights. We decided to do them all vertically. You can also do them in other ways, but we just chose to go vertical. So the bitmap height is going to be or rather the number of frames is going to be the height of the bitmap divided by the height of our display. So it's essentially, you saw that one bitmap was 512. If we divide it by 32, which is the height of the display, then we get the 15 frames. So that's what determines what those little tile grids are going to be, the dimensions of those. Here you can see the tile width and height are set up as the width of the bitmap and the display height. And then this is the advanced image is where we move from one bitmap to the next. This advanced frame is where we move from one tile grid, essentially our animation frame, to the next. And that's done right here with the sprite group, whichever current frame we're on, which is equated to the number of those tile grid subsections. And again, I think that the one that makes this the clearest is that latest one I did, that blobby, and that's because I've created this border around it so that we can see the delineation of those frames. And let's see, yeah, then the last thing I was going to talk about, if anyone is interested, is just some of the methods here of animation. If I show you the layers I've got here, let me zoom out a little. So you'll see I've got a background layer that's just black, and it's just black the whole time, and it also has the frame, and then I also just hand drew those little numbers in the corner. The level is just this blue box, which is on all frames. It's always there. And let me see, did I preserve? Yeah, so here's how I started, was I just simply used a round brush in pixel art terms. I think it's like a 8-pixel round brush. And oh no, I got rid of that. But initially I just animated the ball moving to get the arc and the timing I wanted. Then later I went in, I made another layer, and I started to shape it for this deformation effect that we have. And then I merged those together while I was working because I didn't need them both around anymore. Later I decided I wanted this to be green instead of yellow, so it didn't look so much like Pac-Man. And then I decided to add in an eye. And that allows us to have sort of a, so you'll see here a couple things are going on. One, I mentioned squash and stretch before, so I want to preserve the volume of the ball. So when it comes down to anticipate to jump, I have it fatten out, so it preserves its volume. And same sort of thing happens when it jumps in the air. I have it sort of stretching a little bit in the direction it's going. But you also notice by adding this eye, it gives me something to react as sort of secondary animation. It jiggles a little. It doesn't always track with the ball. So you'll see as the ball starts to raise, the eye is kind of smearing and being left behind a little. Here it will hit and jiggle down and then pop back up into place. So that gives us just a little bit of a secondary motion, which makes the blobby guy feel a little blobbier. And by the way, I recognize that I don't think this is playing back very nicely here, so the animation is skipping around a lot. I can probably, it's probably a little better if I go a little slower through the frames like that. But the video, I think the video captures that pretty well. And then the last thing I did was added in a little bit of blobby matter coming off of the guy. So as he jumps, he's made some sort of sticky slime, and that you can see those each have their own little arcs and life. And what I do is I peter out those pixel colors so they sort of disappear. They just end. They don't have to go anywhere. So if you look back at the one in real life, hopefully that'll give you the playback timing a little better. And at the end, he kind of looks back at where he started, and I loop it. All right, so I think that covers it. Hopefully that's a good explainer for people who are interested in doing animation for your Matrix portal. You can, of course, as you'll see here, it is fun to get existing animation, this little turnaround sprite sheet that I got from a free character on itch.io. And here's a nice little Mario that I have hopping along. Beep, 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 beep. And you can find these. This is from the real sprite sheet from one of the Mario games. I forget which one. There was a little sine wave sort of thing I made. My rings there. Ruby. And I also did a effects animation in CG. So that's a particle system in Maya that, again, I rendered it real small, and it looks pretty cool on the board. All right, so that covers it. Thank you so much for coming by today to hang out. This has been John Park's Workshop. I'm John Park. A couple reminders. I'll be doing another pick of the week next Tuesday, so tune in. And if it's a product that you think is cool, you can probably get it for a good discount on that show. So stop by for that. And I'll be hanging out over in the Discord chat a little bit. I've also got to get to work on writing up some of this info for a guide so that you can build both the sprite. I keep pointing back there. I've got the little sprite display, individual sprite display, or the animation display. All right, so for Adafruit Industries, I'm John Park. This has been John Park's Workshop, and I will see you next week. Bye-bye.